All right, in our last video, we talked about how to evaluate algebraic expressions. In this video, we're going to extend our knowledge, and we're now going to talk about formulas. All right, so what is a formula? A formula is a special type of algebraic equation that tells us a fact or rule and connects two or more quantities. You're going to want to write that in your notebook. And you probably noticed that I said algebraic equation. Up until now, we haven't really talked about equations. We talked about algebraic expressions. So what makes an algebraic equation an equation and not an expression? Well, just like how you can see it has kind of the word equal in it or equate, an equation has to have an equal sign. So far, when we talked about algebraic expressions, we didn't really see an equal sign, right? When we got an answer at the end, it just kind of was a number. It didn't say something was equal to that number. So an algebraic equation will actually give us an equal sign at the end and a value that is probably equal to a variable, as an example. So a formula is a special type of an algebraic equation, and it always tells us a fact or a rule that we know to be true all the time, connecting two or more quantities. So for example, one of the most famous formulas or algebraic equations that we know to be true is for the area of a rectangle. And you've probably seen this again and again, right? We know that the area of a rectangle is equal to, that's what makes it an equation, length times width. So in order to find the area of a rectangle, we know we can always multiply the length times the width to get it. It is a fact, it is a rule, and it's an equation. So this is a formula. Okay, let's take a look at an example involving the area of a rectangle. So example 9 from your book says that the area A square centimeters of a rectangle of length L centimeters and width W centimeters is given by the formula A equals L times W, or LW. Let's pause right there real quick. There's a lot of variables. It kind of doesn't make any sense. But all they're saying right now is that the area, which we'll call A if we were to assign it with a variable, right? Because A makes sense because area starts with A. So all they're saying is that instead of writing area, because remember mathematicians are lazy, we're just going to write a capital A to represent area. Because remember, we're using variables in math to represent unknowns. Right now we have no idea how much the area is. So the area A, square centimeters, that's how we're measuring it in square centimeters, of a rectangle of length L centimeters. We don't know what the length is right now, so we're just calling it L, and width W centimeters. We don't know what the width is right now. We're just using the variable W to represent the width instead of writing out the whole word. Is given by the formula A equals L times W. So all they're saying is instead of area of rectangle equals length times width, they're just rewriting it so that instead of all that, they're just saying A equals L times W. Okay? Just a shorthand way of writing. Now they're saying to find the area of a rectangle whose length is 12 centimeters and width is 7 centimeters. So just like the last lesson where we substituted values in for the variable, that's what we're doing here. So we're taking that formula they gave us, A equals L times W, and instead of, and remember we're trying to find the area, so we don't need to touch this A, that's what we're going to look for later. Instead of L, the length, we're going to add in 12 centimeters. Okay, I have it in parentheses because this is a multiplication problem. So I'm just going to separate my two values, and then I know since there's no sign in between that it basically implies multiplication. So instead of W, they told us W is 7 centimeters. Okay, and I'm writing in the units as well. I'm not just putting 12 times 7 because these units are very important. We know we want square centimeters later, right? Or centimeters squared. So later on, I'm actually going to multiply my numbers and my units as well. So all I did so far was I wrote down the formula. I substituted in 12 centimeters for the length, substituted in 7 centimeters for the width. And then now I'm going to solve. 12 centimeters times 7 centimeters. Well, first 12 times 7. 12 times 7 is 84. And then centimeters times centimeters. I can write that out for you. Or you can know already that it's centimeters squared. And remember, area was in square centimeters, so we want centimeters squared at the end. If you don't put in the units, you might forget that and then just get 84, which is technically incorrect. Okay? And remember, we didn't touch this A, so you can rewrite it if you want. So at the end, A, or area of the rectangle, is equal to 84 centimeters squared. So remember, an equal sign means you have an equation. So at the end, our area is equal to 84 centimeters squared. Let's take a look at another formula problem. This one says, given the formula, S equals 1/2 times n times the quantity of n plus 1, find the value of S when A, n equals 10, and B, n equals 17. And just as an interesting math fact, this is a real formula. And when you solve it, you can figure out the sum, or the answer to an addition problem, the sum of the first n positive integers, as long as you know what n is to put in. Okay, so for example, if I wanted to figure out 1 plus 2 plus 3 plus 4 plus 5 plus 6 or whatever, all the way up to an unknown amount for n, no idea when I'm stopping, then you can put it into this formula and it'll tell you the sum, what happens when you add those all up together. Okay, so the n is just telling you where you're stopping when you're adding. So A is just saying that they want to add up all the numbers starting with 1 going all the way up to 10. For B, they want to add up all the numbers going up to 17. So this handy little formula actually gives you the answer instead of you punching it all into your calculator or adding it up by hand. Okay, go ahead and pause the video. Try this problem on your own first. All right, let's try A. So I'm going to write down my formula. S equals 1/2 times n times the quantity of n plus 1. And then I'm going to substitute what I can inside. N equals 10. So instead of 1/2 times n, it's 1/2 times 10 times, because remember there's another multiplication here, 10 plus 1. So at the end, I need to, remember with PEMDAS, solve what's inside my parentheses first. Inside my parentheses is 10 plus 1. 10 plus 1 is 11. And then at the end, I just have multiplication across. So 1/2 times 10, half of 10 is 5. And then at the end, I multiply 5 by 11, I get 55. So the sum of the numbers 1 through 10 is 55. Okay, let's try B. S equals 1/2 times n times n plus 1. Okay, so S equals, let me actually move it over a bit so I have room. S equals 1/2 times, let's see, n is now 17 times 17, what is it, plus 1. Okay, so again, I solve what's inside my parentheses first, and 17 plus 1 is 18. Half of 17, well, half of 16 is 8, so this would be 8.5. Let's put 8.5. Half of 17 is 8.5. Multiply that by 18. 8.5 times 18 will be 153. So the sum of the numbers 1 through 17 is 153. That's way easier to use the formula rather than adding it all up by hand, right? Okay. Let's do one last formula. This one says, if S equals U times T plus 1/2 times A times T squared, find the value of S when U equals 20, T equals 3, and A equals 10. Go ahead and pause the video and try it on your own first. All right, let's try it out then. So S equals U times T plus 1/2 times A times T squared. I don't think this is an actual formula, I know. It could just be made up. All right, so let's replace U with 20. Let's not write the X. Let's do our dot. How about that? 20 times T is 3 plus 1/2 times A is 10 times, let's see, T again, 3 to the second power. Okay, now remember PEMDAS. I don't have any parentheses. I do have an exponent, so let's try that first. 20 times 3. These I'm not touching, so I'm just going to rewrite them. Times 3 squared is really 3 times 3, which is 9, so I'm rewriting as 9. Then I'm doing multiplication or division, whatever I see first, left to right. 20 times 3 is 60. Everything else is rewritten down. This is one big multiplication problem. So 1/2 of 10 is 5, and then 5 times 9 is 45. So all that gets reduced to 45. So you get 60, which we didn't touch, plus 45, and then that would be 105. So the final answer here is 105. Formulas, very handy.